Welcome to the 5.8 notes. In this section, we're going to be talking about something called inverse functions. There we go. So an inverse function is a function that undoes the action of another function. The way we will write this is if the inverse, or if the original function is f of x, then the inverse looks like this. It's got like a power of -1 there. It's kind of like x and x to the negative first, which would be 1 over x. They would cancel each other out. There are a few rules we're going to talk about with these. The first one is, how do we decide if two functions are inverses? What does this actually mean for them to be inverses? What it means is if you compose them together or plug g into f or plug f into g, you should get the same thing, and both of their answers are just going to be x. So all the directions for this section will say, determine if f of x and g of x are inverses using composition. That means take one, plug it into the other, and see if you get x. If you do, then they are inverses. If you don't, then they are not inverses. So it does not matter which way you try it. In fact, I will do both ways just to show you. The first way I'm going to do is I'm going to take this and I'm going to plug it in for x right here, which is going to look a little messy for a second. So I need to do 2/3 times all of this. Oops. Copy error. That's a -9. And then the +6 stays outside. Okay, now I know that several of you are going to be like, there's fractions. That's okay. I'm going to show you how to deal with it in your calculator, even if you're using your phone calculator. 2/3 is just 2 divided by 3. And then you want to multiply it by 3 divided by 2. So when you see these fraction bars, those are just division. And it doesn't matter if your phone is giving you answers in the middle of this, it's going to end up being 1 anyway. So take a second to try that on your phone if you need to. Then I'm going to do 2 divided by 3, but times -9 this time. That's -6. And then I'm keeping that +6 here at the end. I do not multiply this by the 2/3 because it's not part of the substitution. It was just already at the end. And then I'm going to simplify. -6 plus 6 is 0. So this whole thing just equals x. So that means that these are inverses. And just to prove it to you, I'm going to take this and plug it in over here instead to show you that it doesn't matter which way you check. So this one, plugged in over here, will have a 3/2 out front. 2 over 3, x plus 6 goes in my parentheses. And then the -9 is left at the end. So the only thing I'm changing is this x is now what was over here. 3/2 times 2/3 is 1. 3 divided by 2 times 6 is 9. And there's this -9 here at the end. And look at that, I get x both times. The only way for these two to end up being the same thing is if they are both x. One x, nothing else, no other exponents. So as soon as one of them solves to be x, you do not have to check the other one. You can if you want to be extra certain that you got the right thing, though. Now let's talk about this one over here. We have x squared plus 6 for f of x. I'm going to take that and plug it in over here. So it's going to have the square root still, but instead of x, I'm going to put x squared plus 6. And then there's this extra -6 out here. And then 6 minus 6 is 0. And this one ends up just being x. So these are inverses as well. And at the end of notes, I'll go back to the assignment and do one that's not an inverse so you can see what that looks like. All right, now let's talk about coordinates. If a comma b is on f of x, so if that's a point on the original graph, then b comma a is on the inverse. So this general rule here is that if you're trying to find an inverse, if you're not just trying to check to see if they're inverses, but if you want to take this equation and figure out what this one is without already knowing, then what you're going to do as a general rule is swap x and y. So between an inverse and the original, x and y sort of just switch positions. So if f of x has points at 4, 8, negative 2, 5, and 1, 3, then the inverse is going to have points at flip these two, flip these two, flip these two. Oops, sorry, I forgot to actually flip those. 3, 1. Okay, and that kind of leads us into the next thing, which is to find an inverse. Step 1 is what we just practiced up there. Swap x and y. But then at the very end, we don't want equations that aren't solved for y, so we need to solve for y afterwards. So for example, on this first one, f of x is the same thing as y. It's probably the first thing you need to know. Okay, these two are the same thing. Then to find my inverse, I'm going to switch the positions of x and y. So they are literally switching spots. And then I need to try and get this y by itself. So what I'm going to do is I'm going to get rid of the 3 by subtracting. The trickiest part about this is you're not actually subtracting the 3, you're just writing it on the other side, except for now it's negative. And then to get rid of the 1/2, we need to multiply by 2. Because 1/2 times 2 is 1. But when I multiply that 2 over here on the left side, I have to multiply it to this whole thing, like this. So that'll actually be 2x minus 6 equals, and then this 1/2 and the 2 cancel, and it's just y. So y equals 2x minus 6, and then I'm going to change that to the inverse, equals 2x minus 6. So keep in mind that the inverse is just f of x, but with this little -1 right here. That means inverse. And then it wants us to graph both of these. This is back to graphing lines, everybody. This one's going to start at 3, and it has a slope of 1/2. So it's going to go up 1, right 2. Like that. And you guys don't have to do this, but you know that I always continue my dots till I get to the edge of the graph. And then the inverse is going to start at -6, and it has a slope of 2 or 2 over 1. So I can go up 2 over 1. A little bit of a blast from the past there. We haven't talked about slope in a while. And there you go. And then we're going to do the same thing over here on the right side, where this is really just y equals 2x minus 5. And then we're going to swap x and y. So it's going to turn into x equals 2y minus 5. And I want to get y all by itself. So I'm going to add this 5 to the opposite side. And now I have x plus 5 equals 2y. And to get rid of the 2 in front, I need to divide by 2. Now, we are going to divide both of these by 2. X divided by 2 is just going to become 1/2 x, because there's a 1 right here. And the 5/2 is just going to be 5/2. Now, you might be like, why is she doing that? Why is she separating it? Why didn't she just leave it as one fraction? I want it to be slope-intercept form. So I need a fraction in front of x and a fraction at the end, essentially. And then I'm going to write this as my inverse down here. The reason why this last step is so important is the whole reason why we don't just use y anymore. Because I need to know that this one was my original and this one is my inverse. Otherwise, I don't know which one's which anymore. So the original is going to start at -5, and it has a slope of 2, or 2/1, just like the inverse did on the other problem. So I'm going up 2/1, like that. And then my inverse starts at 5/2, which I know is a little weird. That is basically 2.5. So I'm going to go 2.5 and put a point there. And then my slope is 1/2. So here's the thing. I can go up 1/2/1, and that's my next point. But really what this slope means is you're going up 1/2. So once I get back to my whole number, I'm going to go up 1/2. Or you can keep going up 1/2/1 and realize you're in the same place. Just realize that every other point, if you keep going up 1/2, will be on a corner instead of 1/2. Just like that. Now, you'll notice that there's kind of a little bit of a pattern going on here. There is a special relationship between the graph of f of x and the inverse. It is a reflection over the line y equals x, which I'm going to go draw. So the line y equals x starts at 0, 0. There's no number being added right here. And it has a slope of 1. So it kind of goes like right down the diagonal middle of the graph. Okay, so if I draw my dashed line through here, see how if you flip this one, it becomes this one? Same thing happens over here. And you can always draw that to see if you got yours correct. All right, now let's talk about a couple of things on the backside really quick. We're going to find the inverse again, except for we're not going to graph these because some of these get a little complicated. So the first thing I'm going to do, this is the same thing as y. I need to swap x and y. Okay, and I need you to think about these as like opposite operations. I need to get rid of that cubed. How do I do that? Cube root. So that then the cube root and the 3 cancel. So I have the cube root of x equals y plus 4. And then how do you get rid of a plus 4? Minus 4. Here's the part where it does get just like a little bit tricky. It's just the cube root of x minus 4. You can't combine those two together. And technically I should write this as the inverse, f inverse of x equals the cube root of x minus 4. So that I know that this is my inverse. If you just leave them as y's, then it's kind of confusing. And then I'm going to do the same thing over here. This is my y. First thing you need to do is swap x and y. So it's going to be x equals the cube root of 2y plus 1. So step 1 in finding an inverse is to switch x and y. Then you got to figure out how to get y by itself. This is kind of like the opposite of the one before it. I need to cube both sides to get rid of this cube root. So I have x to the power of 3 equals 2y plus 1. You're going to subtract that 1 to the other side and divide by 2. So I get that my inverse is x cubed minus 1 over 2. And you are perfectly fine to leave it like this. The only reason why I switched it on the front side, guys, was so that I could graph it. So if you don't have to graph it, you can leave it like this. Otherwise, you could also write this as x 1/2 x cubed minus 1/2 if you really wanted to. I wouldn't count you off for doing that. You just don't really need to unless you're trying to graph it. And then I'm going to show this next one without doing this part first. I'm just going to show you it'll be x equals y plus 4 over 3. You're just switching spots. And then to get rid of that 3, I need to multiply by 3, because the opposite of dividing by 3 is multiplying by 3. So now I have 3x equals y plus 4. And I need to subtract that 4 to the other side. And now y is all by itself. So that's my inverse, 3x minus 4. Okay, and you can almost do this in your head by thinking, I'm going to multiply by 3 to get rid of this, and then I'm going to subtract 4. So it's going to be x times 3 minus 4. Okay, and then the very last part, only functions that pass the horizontal line test have an inverse. We've done the vertical line test before. Think of it as drawing a horizontal line through your graph like this. And you can draw anywhere you want. I'm just drawing them in the same spot to get started. If it crosses more than once like this, then it does not have an inverse. This one only crossed once, and it gets a little iffy right here, but it still only crosses once no matter where I go. So this one has an inverse. And then this one crosses twice. So you'll notice that none of these were x squareds. That's because they don't have an inverse. And there it is.